Hi everybody, welcome to week 16. We are working on the end of unit 4, so we're going to do 4.08 through 4.14. If you're in the room with me, then you have a copy of the notes. If you are at home, then you need to have printed those out. So give me 1 second. Too far. Hang on, Christy, I'm working on it. Okay, fabulous. Christy, I think I have you all set up and ready to go. So for week 16, your essential question is going to work a little bit differently this time. I'd like you to keep track of all of the answers on your notes paper today. And at some point during the session, I'm going to say, this is the one you put in the Dropbox. So pretty easy. If you're here in person, you're getting the credit. If you're at home and you're paying attention, you're going to have it on your paper, and you'll just circle it and know to submit that one to the Dropbox today. So any questions about that? So again, I'm not telling you which one it is. We got to take good notes throughout, and then when we get there, I'll be like, this is the one to put in the Dropbox. Like, I'm not trying to trick you. Just making sure those of you at home watching the recording are taking really good notes. Okay, so let's begin. We're going to do a review of what we learned last week, which was our angles formed by secants and tangents. So let me give you a picture. This is the formula that we worked on at the end of last class. So let's look at it and see if we remember. It shows two intersecting secants, and they're intersecting inside the circle, and this is when they hit not in the middle, right? This was our essential question last week, actually, was what was this formula? So the formula is we add our two outside arcs, and we divide by 2, and that gives us that angle. We talked last week, once we know this angle, we also know the alternate angle because they're called what kind of angles? What's the word? Vertical. Very good job. And then we'll actually work on finding that third angle as well on our first example. So let's try one before we move on. So if I tell you that this outside arc is 10 and this outside arc is 32, can you please write it on your paper? Let's find x. Go ahead and try on your paper. So I have two secant lines crossing inside the circle. They're not crossing in the center of the circle, so we're not talking about a central angle. Everybody finished? If you're at home, green check mark if you're finished. Here in the room, are we done? Yes? Yes. Great, thank you. Awesome. Okay, so let's see. 10 plus 32 divided by 2. Right, so I get 42 divided by 2. So what's x? Everybody says? 21. 21. Or Anthony says, great. So if x is 21, we automatically know that the angle straight across from that is also 21. Can you please label that on your paper? Because they are vertical angles, as Destiny said. Now I know it doesn't ask you this on here, but we're just taking it a step further. Am I able to find this angle? The one that I'm pointing to with the pointer finger. Am I able to find that one? Yes, I am. So let me change colors here. Because we know on a test, they like to ask us to find all kinds of different angles. So yes, I can find this pink angle. What do we know about the 21 and my pink angle? If they're on the same line, those are called what kind of angles? Starts with an S? Supplementary angles. Thanks, Sabella. And we know that supplementary angles add to be 180. So if I'm going to try and find my pink angle, we would say 180 minus 21. Can you guys make sure you have these in your notes? So we're finding my pink angle right now. If you just only have a pencil, what I would do, since you don't have two colors maybe like what I have, draw in this angle and then point to our formula so that you know which portion of the picture this is referring to. So just point to your formula. And 180 minus 21, what would that give us? 159. So my pink angle would be 159, and its vertical angle would also be 159. So using this really easy to use formula, we are able to find all 4 of the interior angles. Questions, comments, concerns? This was what we ended with last week. It's just a quick recap before we move on to new stuff. Are you saying this is easy? Yes, I see some heads nodding. Great. Okay, that's just the answers. So now we're going to move into our first new section of today, which is on segments of tangents, secants, and chords. When you guys hear the word segment, what do we think of? What do you think of when you hear the word segment? If tangent is a line, what would a segment be? A part of a line, exactly. So when we hear that word segment, we're really talking about just a little piece of the tangent line, a little piece of the secant line, or a small piece of the chord. So here's a new formula for us. Here is a tangent line. What makes it a tangent line is that it touches the circle how many times? Once. What makes it a tangent line? Touches the circle once. So the part highlighted in red would be called a tangent segment, right? A piece of the line. So with your pencils, can you please take your pencil and just make those segments a little bit darker right in there so that they pop out for us. So first question is, are we able to identify them if I give you a picture? The answer should be yes. They're just a little piece of the tangent line. Now how are we going to use that? I'm going to give you about 2, maybe 3 different formulas today. Here's your first formula. This says 2 tangent segments of the same circle that intersect in the exterior, can we underline that word exterior? Are congruent. That's good information to know. That means if you have a segment and a segment that meet outside the circle, see how P's outside the circle? We know that they are the same. That's going to be a good piece of information for us to know. So how are we going to use this? Let's plug in some numbers, let's plug in some variables, and let's try it. If I show you this picture, it's the same picture as before, but now I'm giving you values for AP and BP. Let's draw on our picture. It says AP is 3x plus 4. So where are they talking about? They're talking about A to P, 3x plus 4. Can we add that to our picture, please, in your notes? And BP is x plus 16. That means the other side is x plus 16. They want me to solve for the distance from A to P and solve for the distance from B to P. I have lots of variables going on, but what do I know about those two? They are what? They are the same. What does the same mean in math? They are congruent, which means what symbol am I using for math? They are What did you say? Somebody said it. Equal. They are equal. So I'm going to put an equal sign in between those two. So my 3x plus 4 is going to be equal to my x plus 16. That's what congruent means, right? Congruent means they're equal. So if there's things in there that I don't know, like my variables, how am I going to find them? I have to set them equal to each other. So let's do a little algebra 1 here. Let's get all my x's on one side, all my numbers on the other side, and let's solve. Okay. When I move variables, and again, this is just an algebra 1 technique, on one side I have a 3x, on the other side I have a 1x. You can move them to either side that you want, but so that you're dealing with less negatives, I always let my big one stay put. I think of it as the lazy one. It's the bigger one, it's a little bit lazier, so it's going to stay put. My little one's going to be the one that moves. So I'm going to move the x over. So I get 2x plus 4 equals 16. Now I'm going to get my x by itself, so we'll move the 4 over. And hopefully this is old hat, right? Like we've been doing this for ages. This is fine at this point. And so I would get x is, everybody says? 6. Yeah. So 16 minus 4 gives us 12, and then we divide by 2, we get 6. Is that what the question wanted to know, yes or no? Let's look back up there. It says solve for A to P. Is the length of A to P 6? No. No. What does the 6 really mean? 6 is just my x. What do you think I need to do with my 6 to solve from A to P? I have to plug it back in. So sometimes on a quiz and a test, do you think they would have 6 as an answer? Yes, they do that to us. They're making sure, did you read what they're really asking us for? So we're going to take the 6 and we need to plug it back in. So let's go back up to one of them. 3 times 6 plus 4. So that would be 18 plus 4, which gives us 22. Which one do I plug it in for? Do I plug it in the top or do I plug it in the bottom? Good job, Tyler. Tyler said it doesn't matter because they're congruent, which means they're the same. Just to check, let's try. If I put in a 6, what's 6 plus 16? 22, same answer. Okay, good job. Any questions on any of the steps? They're congruent. We set them equal to each other. Once we got our x, that's not what they wanted. That's not what they were asking us for. We had to plug it back in and finish solving for the 22. Good job. So far, so good? I told you today, if you can multiply today, you're going to have a great day in geometry. Those are just all the answers. Okay, next theorem. Now we're going to have two chords that intersect in the interior of the circle. It says the product of the segments of one chord is equal to the product of the segments of the other chord. Let's break this down. The word product means what? It means multiply, exactly. It's the answer to a multiplication problem. So what are they really saying here? They're saying if I take this segment of the chord, AE, and I multiply by EB, that's going to be the same answer if I multiply the other portion of the chord times its partner. So chord times chord equals chord times chord. We okay with this theorem? We're going to try it in a minute. So it has to be same chord times itself, same chord times itself. They equal each other. Let's try one with numbers in it. Okay, are you adding your numbers to your picture? That should always be our first thing. They're giving us lots of information here. Let's mark up our picture. So my AE is 2x plus 2. My EB is 6. My CE is 4x. And my DE is 4. So what did the last theorem tell us to do? Multiply the portion of its chord times its partner equaling the portion of its chord times its partner. So let's write all that over here. We're going to have the 2x plus 2 times 6. I can't write it like that though. Can somebody help fix what I just did? I did it like that on purpose. How can I do this whole portion of the chord times 6? What do I need to rewrite it as? What did I do wrong? I need parentheses, because I have to do the whole term times 6. So we're going to put that whole 2x plus 2 in parentheses. Everybody okay with that? One whole section times the other whole section. That's going to equal my 4x times 4. So just relook at your picture, make sure this makes sense. 2x plus 2 times 6, and the 4x times 4. Let's solve it. How am I going to solve this portion in parentheses? I have to use starts with a D. D. Distribute. Thank you, Daniel. Let's distribute. So I'm going to get 12x plus 12 equals 16x. Please finish solving on your paper and write down your final answer for me. For those of you at home, please feel free to type in your answer when you're ready. So we should have moved our 12x to the other side, and we're left with 12 equals 4x. 4x. So my x is 3. But I have to come back to what is the question asking us for? Did the question ask us what x was, or did it ask us something else? Let's look. The question said, find AB and find CD. So they want to know What's this whole length? And what's this whole length? They're asking you for the whole length of the chord, not what x is. So what do I need to do with my x? Plug it back in. So here I would get 2 times 3 plus 2. So 6 plus 2 is going to give me what? 6 plus 2? 8. And then this section is 6. And then over here, if I plug in 4 times 3, this section would really be 12. And this section is a 4. So what are they asking me for? Find AB. So let's all look on my picture to find AB. A to E is 8. E to B is 6. So what is the whole length if this portion's 8 and this portion's 6? What's the whole length? What's the whole length? I'm going to highlight it in a different color. Okay. This section's 8, this section's 6. So what's my whole blue section? Anybody in the room? Want to try? Close. 8 plus 6, 14. Okay, so A to B was 14. How about C to D? C to D is 12 plus, what's the other one? 4. So C to D is 16. Everybody okay? They're allowed to be 2 different numbers. They're allowed to be 2 different numbers. Okay, so this one might just take some practice. Have you seen this yet? I think this was yesterday's stuff. Pretty new stuff still? Okay. So some of you probably just have not gotten there yet. Does anybody have a question about anything on the screen though, after we did the steps together? The number one mistake I see students making is you find what your X is and you think you're done, right? And even some of you in the room are like, oh yeah, I didn't quite get all the way to those answers. Just forgot to plug them in, then forgot to add those lengths together. Let's try another one. So here is our last, I guess we have two more formulas for today, but they're pretty much the same formula. This is if we have 2 secant segments. So what's a secant? Again, it passes through the circle 2 times, not through the middle. So a secant is something that passes through 2 times. So here's your formula. It says A times C times B times C. So what does that mean? A times C is the whole thing. B times C is the outside. So I kind of put it in words for you down here because in words makes more sense than talking letters, I think. It's the whole side times the outside equals the whole side times the outside. So hopefully that makes a little more sense than the letters. Whole times the outside, whole times the outside. So let's try one. First, let's mark up our picture with our numbers. So I have AC is 10. Please add a 10 into your notes. BC is 8. Let's add an 8 into our notes. Then on the bottom it says EC, so let's draw on our line, 2x plus 2. And DC is 5. Ooh, I like what it's asking us to solve for this time. Look what it says. Solve for x. That means after we do the math, the original math, we're going to be done. Because it's not saying what's the length, it's just asking us what x is. So what's my formula? The whole times the outside equals the whole times the outside. So let's start with the top. The top, what's the whole? Actually, I'm going to write those words in. Whole times outside equals whole times outside. Now underneath these, let's just fill in our numbers. Everybody ready? Okay, so the top, what's the whole of the top? 10. What's the outside of the top? 8. Great job. So far, everybody okay? Whole times outside. Instead of x, I'm going to do a dot though. Equals. Now on the bottom, what's the whole of the bottom? 2x plus 2. What's the outside of the bottom? 5. it just becomes a multiplication problem. This is Rect Algebra 1, just a couple steps to solve, and you will be all done. So take about 30 seconds, finish it up. I'm going to walk the room, check on you. If you're at home, go ahead and type in your answer. All right, those of you at home, try it out. You should have had 80 equals 10x plus 10. You move the 10 over and we get 70 equals 10x. So x is 7. X is 7. Great job. Most of you, when I walked around the room, you guys had that answer. If you are lost on any of these steps down here, please let me know. I can definitely help you after the fact because that's old Algebra 1 stuff, but I don't mind going over it with you if you need it. Let's try another one. Okay, this time we're going to write our numbers in. It didn't print out with the numbers on it, so I'm going to give some to you. So please add these to your paper. A to B is 12. A to B is 12. B to C is 6. So again, you're adding these to your notes because they didn't pre-print on this one. And then D to C is 3. And the whole thing is 2x plus 4. So I'm giving it to you in a slightly different manner than I gave it to you in the last problem. So before we try and plug numbers in, let's write these words on our paper. Whole times, which order did it go? Whole times outside equals whole times outside. Order really doesn't matter when we're multiplying, actually, right? Because it would be the same either order. But I just want to stay consistent. So whole times outside equals whole times outside. Just going to abbreviate with the word out. So let's all start on the top of my picture. Be very careful here. What is the whole of the top?
18.
Good. Why is it 18?
Because whole and 6 is the whole thing. It's not just 12.
Good. Because 12 and 6 is the whole thing. So the whole thing is actually 18. In the picture, they may not say 18, but we know that whole really means that entire length. So we might have to add them together ourselves sometimes. So the whole is 18. And what would the outside of the top, Daniel, be? Oh, that's the hole on the other side. What's the outside of the top? 6. Good job. And then on the bottom, the hole would be our 2x plus 4. And the outside of the bottom is 3. So the only tricky part on this one was that I didn't give you the whole. You had to just add them together yourself. So not really tricky once you have the words down there. So if we work this out, 18 times 6 is 108. And then on the right side, we're going to distribute. Please take a moment and finish solving this one. Get x by yourself. So first you have to find x, and then we'll talk about if you're done or not. Should be an even number, no decimals. Okay, so you move the 12. We get 96 equals 6x. We divide by 6, and we get x equals how much? 16. Great job. Now the question becomes, am I done? Is that what it's asking me for? Do I have to do something else? No, I'm not done, because look at the question. Find the missing length. Well, it gave me 12, it gave me 6, it gave me 3. The only missing length I have is this one. So let's plug in our 16. 2 times 16 plus 4. Good job, Jared. 36 would be my missing length for C2E. It's important that we label it too, right? That's the whole thing. Yeah. No, not in this one. The question was, were we supposed to find E to D? And the answer is no, because they didn't give us any info about it. They're only giving you a variable for the outside length, so that's the one they wanted you to find. Good question, though. Did the second one go a little bit easier? Just a new formula, right? Whole times outside equals whole times outside. Like most of geometry is not that hard. It's just remembering what formula to use when. But if you keep these notes with you, I was telling the students in the room, don't turn in your original papers to your homeroom teachers for work samples. Make a copy, keep a copy, because there's really great formulas in here that give you a picture of here's when you use this formula, here's when you use this formula. So keep a copy for yourself. Now my last formula is this one. This one is almost the same as the last one. This time it's whole squared equals whole times outside. Think about the last one we did. Didn't we do whole times outside equals whole times outside? How come on the top we can't do whole times outside, whole times outside? Look at the last one we did. This time we could do whole times outside, whole times outside. Why can't I do whole times outside this time? There's no inside this time. Do you guys see the difference? There's only one segment. You don't have two segments. So when you only have one segment, what do? You do that segment twice. You're doing that segment times itself. That's where the square comes from. So it's really the same formula as last time, to be honest. It's just you don't have two different segments. You only have one this time. So we're using it twice. So let's try it. Here we go. It says, given that AB is 12, so let's add a 12 to our picture, and that EB is 18, DB is 3x minus 4, solve for x. So let me give you a moment to try and set it up on your own, and then I will show you how we do it. But let's write out our formula. Whole squared equals whole times outside. So take a quick minute and see how far you can get on this one on your own. All right, so here we go. Whole squared, so that would be 12 squared equals your whole 18 times times the outside, 3x minus 4. 12 squared means 12 times 12, so not 24, right? I saw most of you get it right in the room. 144. What do I have to do with the 18? Distribute. So 18 times 3x is 54x, and 18 times 4 is 72. Are we all right? Calculators are acceptable. I've told you guys that before because a calculator can only do what you tell it to do, right? Calculator can't solve all this for you and know the right answer. You obviously have to know what you're multiplying together. So I'm absolutely fine with you guys using calculators. So we're going to add 72 to both sides, and we get 54x equals 216. We would divide both sides by 54, and we get the x is 4. 216 divided by 54. We get 4. Let's look. Are we done? Is that what it asked us for? It said solve for x. Yes, that's what we did. So we are done in this problem. Questions on any of my steps up there? I think it makes a difference if you write the words whole squared, whole times outside. It really makes a difference because then right underneath it you're plugging in your numbers from the picture. Questions before we move on? All right. Let's do one more. Again, the example problems this one didn't print the numbers, so we're just going to add them ourselves. A to B is 6. D to B is 5. And E to B is 2x minus 3. I'm going to change the directions though. I'm just going to say cross off find the missing links, just put find x. This time you will have a decimal answer just to prepare you. So let me give you a couple seconds to get going on that one. So hopefully you set up your problem very similar to mine, and by the time we are done, we get that x equals 51 divided by 10, which would be a 5.1. Okay, if you didn't quite get there, you can ask me to check your steps a little bit later. We have 2 other sections to go over for, that was the last of the formulas as far as circles go, like the arcs and the tangents and the chords. That was the last of the last for that. We have 1 more section to cover before your test next week, so this will be your last session with me before your next test, so that's why I want to make sure we get through it, even though you're still going to be covering circles on Monday. And I think Tuesday's a review day, Wednesday is your test, I believe, if I'm thinking through the calendar correctly. But this part's fun. This is how we graph circles. And you're thinking, oh, graphing. No, it's easy. You just need to know 2 numbers in order to graph a circle. So what's the coordinate plane again? A coordinate plane is a x, y axis. So we're going to be graphing circles on a coordinate plane. And once you learn these 2 rules, you're going to be golden, and I don't want you missing any questions on your quizzes or tests on circles. So here's this crazy equation for a circle, and you're thinking, yikes, there's lots of numbers up there. There are, but I just want you to circle 2 of them. Can you circle your h and your k? So on your formula, go ahead and circle your h and your k. Guess where I find h and k on my picture? Where's h and k? It's the center. Yep. So once you find the center, all we have to do is we plug in our 2 numbers, and you are done. Easy. Super, super simple. So your h and your k is your center. So here we go. We're going to try one. It says write the equation of the circle. So everybody with me, here's my generic formula. Right underneath it, we're going to do a blank equation. So we're going to put x minus, leave a blank, squared, y minus blank squared, and we'll do the r last. So first step, can everybody do this blank equation with me? Watch how easy it is. In place of h and k, I plug in the center point. So look at your picture. Where's your center? The origin. 0, 0. So what am I plugging in for h? 0. What am I plugging in for k? 0. So let's do that. That was easy. Let me simplify that a little bit. Anytime you guys have an equation, do you ever have to write plus 0 or minus 0 at the end of your equation, yes or no? No. So 0 does not change anything. So I'm going to just reduce this, and I'm going to say x squared plus y squared equals. Because do you guys all agree? Minus 0 doesn't change anything. We are just simplifying the equation. The last piece of the puzzle is an r. R stands for radius. All we have to do is look at my picture and count my radius. The radius is the distance from the center to where? The point on the circle. Any point on the circle. It's going to be the same all the way around. So on your picture, count with me. 1, 2, 3. What's our r? 3. So I'm going to plug in 3 for r, and r is squared. So by the time I'm done, I get x squared plus y squared equals, what's 3 squared? 9. You're done. So what are the 2 pieces of the puzzle for writing equations of circles? Plugging in your center and plugging in your r. That is it. That's it. That's it. Let's try again. So I have this picture for you in your notes already. We are going to write a blank equation. See how I started it for you? So everybody so far, please fill in x minus and y minus. So everyone on your notes, let's fill in x minus and y minus. I like having a highlighter, but I know you guys probably don't have one handy with you. Okay, what fills in the spot of my highlighter? The what? The center. Yeah, the center is going to go there. So in place of my first highlighted spot, which number am I going to plug in out of my center? I'm going to rewrite it so that it's nice and big over here. My first highlighted spot, Which one do you think goes there? The -3. Think about it. This is x. You put your x in there. That makes sense. Here's your y. You put your y in there, right? When we have a center and we have an x and a y, that's where they go. So I'm going to put in my -3 in here, and I'm going to put my 1 in there. So let's all do that. -3 and a 1. Ooh, what happens on the left now? Savella already said it. What happens right here? It's going to become a plus. So it's going to be x plus 3 squared plus y minus 1 squared equals r squared. Can you guys count your r for me? They kind of gave it to you in the picture. Tristan, what do you think? 4. 4 squared. Did you have a question? Or you're, okay. Any questions on how that worked? So let's kind of take a peek here. Why did it become a +3? Because it was a double negative. Everybody all right with that? What if I gave it to you backwards? Would you be able to take this and graph it? The answer is yes. If we can go one way, we can go the other way. So let me have you think about this. If you see a +3, where is your center really at? -3. See what I mean? If you have a -1, where's your center really at? A +1. So the center is really at the opposite of what you see in the formula, because our original formula is already minus. So whatever you see in parentheses, your center is really the opposite of that. So let's keep that in mind, and we will try one. So here is my formula, and I want you to graph it. No, we can do it. Easy. So if we see a +4, let's think about my center. Where's my center at if you see a +4? -4. If we see a -2, where's my center really at? +2. Can you guys please graph your center? Once you have your center, I only need one more thing to be able to make a circle. You need your radius. It's telling us that there's a 9 over there. 9's not the radius. 9 is r squared. So what's really your r, guys? 3. Your r is 3. Great job. Because it's really the square root of what you're seeing. So in every direction from our center, I'm going to put a C there to remind us it's our center. We're going to go 3 spaces. 1, 2, 3. Let's go up 3. 1, 2, 3. Left 3. 1, 2, 3. And down 3. 1, 2, 3. And if we drew in a nice smooth circle, because we know that it's a circle, I can't draw to save my life. Hopefully your circle looks better than mine. Okay. Any questions on this problem? How did that one go? Okay? Okay. This is the problem you were putting in the Dropbox. How are you putting in the Dropbox? You are going to put this. What's your center? What's your radius? If you're at home, can you give me a green check mark that you know to use this for your week 16 essential question, please? Okay. Those of you that are paying attention, it's an easy way to earn 10 points. If you're not paying attention, you're going to have to go back through the recording until you find it. So C is -4.2. Your R is 3. That's what you're putting in the Dropbox for your essential question today. Okay. No, those of you in the room, you get credit for signing in. So, yeah. No, not extra credit. You're 10 points. Okay, let's do one more. This asks us to find the equation of a circle when x minus 3 squared plus y plus 5 squared equals 36 after it has a translation. So what does a translation mean? A translation means that we're going to take our circle and we're going to slide it somewhere else on the graph. In order to know what it's going to look like, though, we need to graph the original. So everybody with me, we are going to graph that original. I forgot to highlight the 36. So step 1, we're going to recognize what our center is. Step 2, we're going to identify what our R is. So let's all start with the center. If I see a -3 next to x, What's my center? Positive 3. Great job. If I see a positive 5 next to y, what's my center? What is it? Negative 5. Great. If I see 36, is that my r? Do I have to go 36 spaces in all directions? No, that's your r squared. So I have to think about what's my r? What number squared is 36? 6. Everyone okay with that? 6 squared is 36, so we're just thinking backwards. I would like everyone to graph this original. Graph your center, graph your new radius, and let's see what kind of a circle we're talking about. So I'm going 6 spaces in all directions. Notice I don't do my diagonal because those are not going to be perfect square boxes, right, for me to count 6 spaces. Just by doing your 4, you're able to make a pretty good looking circle. Hopefully yours is better than mine. That's the original. That's not what the question's asking us, but I want you guys to understand, number one, we got to practice graphing another time, but also what's happening to it as we apply this transformation to it. So look what it's telling me to do. It wants me to translate it 4 units left and 2 units down. Which of those dots would be the easiest to move? The center. So we're going to take the center and we're going to do what it's asking us to do. So everybody look at your center. It wants me to go 4 units left. Can we all count 4 units left, please? I'm going to change colors. We're going to go 4 units left. 1, 2, 3, 4. And then it wants me to go 2 units down. 1, 2. This is your new center. That's not so hard. Once we had it graphed, we can shift it. Once we shift one thing, the whole circle would be shifted, right? So from my center, I could still go up 6, 2, 3, 4, 5, 6. I could graph it all over again. 1, 2, 3, 4, 5, 6. I think you guys kind of get the idea. And this would be my new translated shifted circle. So what is it asking me for? It wants the equation of my translated circle. So everybody do this with me. Let's write a blank equation. And we just got to plug in our numbers. So I'll wait for you guys to catch up. So all it wants me to plug in is my H and my K. Where's your H and K? At the center, the pink center, right? The translated center. So here's my pink center. We can even write right on there what my new coordinates are. Let me grab my black. So my new coordinates of this big black center are -1, -7. Everybody okay with that? Over 1, down 7 now. So what am I plugging in for x? -1. What am I plugging in for my k? -7. What's my new formula going to be? X plus 1 squared plus y plus 7 squared. What about my radius? Did my radius change when I just shift the circle? No. So my radius is still 6. So I could say 6 squared or 36. And you would be finished at that point. How'd that go? Circle equation. You need to know 2 things, am I right? 2 things. You need to know your H and your K, and then your radius. What is H and K? The center. That's kind of the big idea. That's all that's left this unit. Yes? Yes. So again, at some point during today's session, I told you which example to submit for your answer for your week 16 essential question points. So if you missed it, you just got to go back, watch that recording, and I hope that all of you guys have a fabulous day, fabulous weekend, and I'll see you next week.